All right, so this is the 6.1 notes video over angles of polygons. The warm-up at the top says write the triangle angle sum theorem in a complete sentence using precise mathematical vocabulary. Okay, our triangle angle sum theorem states that all three angles, or all three interior angles in a triangle add to 180 degrees. Okay, so the three interior angles, which means angles inside of a triangle, add to 180 degrees. Okay, it says right here, a diagonal of a polygon is a segment that connects any two non-consecutive vertices. Non-consecutive means not right after one another. So it says draw diagonals to determine how many triangles each of the following shapes is composed of. Okay, if I were to try to draw a diagonal in a triangle, the only way I can connect one vertice to the other is if it's consecutive, right? Like from here to here, this is the other vertice, but they are consecutive. It's one right after the other. Or from here to here, these are also consecutive, right? No matter where I put my pencil on my triangle, the other vertice is right next to it. So I cannot draw a diagonal in a triangle, so there are none. Okay, but let's say I had a square. Here's a vertice. These are the two vertices that are consecutive or next to that vertice, so meaning I can create a diagonal right here, right? That's forming two triangles, okay, 1, 2. I'm going to put 1 for one triangle right there. When we're drawing diagonals, you have to only draw from one vertex, okay? Yes, I know I can go over here and draw another one, but I'm just going to pick one vertex and then figure out how many diagonals I can draw. So let's say I choose the top one right here. This vertice or vertex is consecutive, but this one is not. This vertice right here, vertex, is consecutive, but this one is not. Okay, so I can create two diagonals which form 1, 2, 3 triangles. Okay, let's say I choose this one. I'm going to connect to all the non-consecutive vertices from this point, which would be 3 diagonals, creating 1, 2, 3, 4 triangles. We should be noticing a pattern here. The number of diagonals is increasing by 1, and so is the number of triangles. Okay, so a triangle has 3 sides and only one triangle. Okay, the sum of the interior angles in a triangle, right, that's our triangle angle sum theorem, is 180 degrees. Every triangle, the angles inside add to 180. Okay, but if I look at a quadrilateral, quad means 4, right? There's 4 sides, right? Here's my quadrilateral, my square, which is a quadrilateral, not the only quadrilateral. I have formed one diagonal which created 2 triangles, meaning that each of these triangles has a sum of 180 degrees in their angles. Like this triangle right here, these 3 angles add up to 180, and so do they in this triangle up here. So if I have 2 triangles, that means I have 180 plus 180, which would make 360 degrees. Okay, pentagon, there are 5 sides, and I had 3 triangles, right? So I'm going to take 180 times 3, which is 540. Okay, right? The number of triangles is increasing by 1, which means that the sum of the interior angles is increasing by 180 degrees, because for every triangle, the angles inside are going to equal 180. So hexagon is 6, there's 4 triangles, so this would be 720 degrees. Okay, the sum of the interior angles of a polygon, right? Polygon just means any shape that has a number of sides is going to keep increasing as the number of sides is increasing. Okay, so let's just talk about the name and the number of sides, right? These are just going to increase by 1, increase by 180. Hepta means 7, octa is 8, nona is 9, deca is 10. You need to know these 7, 8 names and their number of sides. These are the ones that we're going to specify with the name, so you need to know the number of sides. Beyond 10, we're going to write it like this, 18 gone, meaning that there are 18 sides. N stands for the number of sides, okay? So, right here, this is our little rule. The interior angle sum, right, where I'm getting all of these numbers from. Here's our formula that we're going to follow. We are going to take the number of sides minus 2 times 180. Because remember, our interior angles over here is just how many triangles we have times 180. Well, here is the number of triangles. The number of sides minus 2. 6 minus 2 is 4. 5 minus 2 is 3. So this tells us the number of triangles, and then we multiply that by 180 to get the sum of the interior angles. Okay? So, right here, examples 1 and 2, find the sum of the measures of the interior angles of the following figures. Right here, they give me a picture. I need to figure out how many sides does this figure have. So I'm going to count. 1, 2, 3, 4, 5. So this is a 5-sided figure. It is a pentagon, right? I know that it doesn't look just like this, but a pentagon can look like any 5-sided figure, right? It doesn't have to look nice and neat, okay? So I'm going to take 180 times n, which is 5, minus 2. That's going to be 180 times 3, which is 540 degrees. All of these angles, right? Here's angle 1, 2, 3, 4, and 5. These 5 angles are going to add up to 540. These 5 angles don't have to be the same, right? They can all be different measures, but they're going to add up to 540. All right, another thing to note is that the number of sides is always going to be equivalent to the number of angles. Okay, so if I have 13 sides, right, and it's 13, that means I have 13 angles. We need to figure out what are the sum of all those 13 angles. So I'm going to take 180 times n, 13, minus 2, which is 180 times 11. Okay, let me pull up the calculator. So 180 times 11. The sum of those angles is 1,980 degrees. Okay, remember we're adding up angles, so angles are measured in degrees. Okay, and again, guys, the number of sides, as it keeps increasing, so is the sum of the interior angles, right? It's okay if you have a very large sum. That's totally fine. Okay, so example 2. The sum of the measures of the interior angles of a polygon is given. Classify the polygon by the number of sides. So on these examples, we are given the sum, right? Like this is equal to that sum, which is 180 times n minus 2. We want to solve for the number of sides, so I have to solve for n. So I'm going to take that 180 times n minus 2, my formula, and I'm going to set it equal to my sum, right? Because here's the formula for the sum, 180 times n minus 2. Here is my sum. So we're going to solve. The first thing I'm going to do is I'm going to divide by 180, right, to get rid of that 180. Okay, that's going to leave me with n minus 2. So let's do 900 divided by 180. I get 5. All right, remember, that n minus 2, that was the number of triangles, okay? So I had 5 triangles, but that does not tell me the number of sides. I have to add over 2, so n is equal to 7. There are 7 sides, which is a heptagon. Okay, a heptagon. Okay, right here, this is my sum. So we know that 180 times n minus 2 is equal to that 1,620. I'm going to first divide by 180 to get rid of that coefficient in front. And I'm left with n minus 2 is equal to 1,620 divided by 180. And I get 9. And again, that's not yet my number of sides, right? That's the number of triangles, so I'm going to add over 2. So I have an 11-sided figure. Okay, so this is the sum of the interior angles, right? The angles on the inside of that polygon. Okay, so we are going to do these examples A and B, and then I will go to part 2 of this video, but still looking at the sum of the interior angles, right, inside, so we're still using 180 times n minus 2, but we're now going to solve for a missing angle. Okay, so the first thing I need to do is figure out, well, how many sides do I have? Remember, that's equal to the number of angles. I have 1, 2, 3, 4, 5. So this is a pentagon, right? 5-sided figure. The sum of all of these angles, right, 180 times 3 should equal 540 degrees, right? I know that all of these equal 540 degrees when I add them together. So to find the missing angle, right, x, I'm just going to take 540 minus all of the other angles. So minus 111, minus 87, minus 104, minus 138. So 540 minus 111, minus 87, 104, and 138. So my missing angle is 100 degrees. Okay, so same concept for problem B, however, now we have a little bit of algebra. Okay, I'm solving for x still, all right, and now I have a hexagon, right? There's 6 sides, okay? So I know that my sum, when I take 180 times n minus 2, which is going to be 6 minus 2, or 180 times 4, my sum is going to equal 720 degrees. Okay, this one, I can't just subtract all the angles from my sum and then find x, right? I have a little bit more work to do. I have to add all of these angles together and set it equal to the sum. The easiest way to do this is to start with all of your terms that have x. 2x, 2x, 4x, and 4x. I'm going to add all those together. So that gives me 12x. Then I'm going to take all of my constants, right, which are just my numbers, and add those together. 150 and 150, that makes 300. I don't have any constants on these terms. 30 and 30, that's 60, right? So I have 300 plus 60, or plus 360, is equal to 720, okay? So when you don't have a figure where all the other angles are given to you, right, the actual measures, now we have to set up an equation, an algebraic equation, and solve for x, right? We're still going to add up all the angles, set it equal to our sum, but we just have to do a little bit more algebra. Okay, so I'm going to subtract over 360. So that's going to get me 360, and that's equal to 12x. Then I'm going to divide by 12. So 360 divided by 12, I get 30. So x is equal to 30. Okay, so go to part 2 for the remainder of this video. All right, so this is part 2 of 6.1. We left off right here. So in this blank, it is going to be a regular polygon. Okay, so regular. That means that all sides are congruent and all angles are congruent. So at the top of 6.1, when we saw all these nice, pretty figures, right, like this would be an equilateral triangle when all 3 sides are equal, or this would be a square when all 4 sides are equal, right, or my nice, pretty pentagon, hexagon. These are regular polygons, right, when all of the sides are congruent and all of the angles are congruent, right? These are not regular, okay, because clearly not all the sides are congruent, okay? This was not regular, not all of the angles are congruent here, or the sides. But when it is regular, that's when every angle and every side in that figure is congruent, okay? So when I want to find the measure of each interior angle, right, each meaning 1, okay? I'm going to take my sum, right? This is the sum formula. But since all of them are the same, now I can divide it by the number of sides, right? Because the number of sides is the number of angles. So it says, find the measure of each interior angle of a regular nonagon. Okay, so I want you guys to get in the habit of underlining each and then regular, because when you see that word regular, you need to make sure that you understand that it means all sides and all angles are congruent. Okay, nonagon, that means that I have 9 sides, right? So here's a perfect example of, we don't tell you n is equal to 9. We told you the name of the shape. You have to know how many sides is in a nonagon. All right, so I'm going to take this formula, 180 times n, which is 9, minus 2, divided by n, which is 9. Okay, so here's where some mistakes are made, is they think 9 minus 2 is 7, and then they want to divide by 7 down here as well. Make sure you don't do that. We are going to multiply 180 times 7, but then we are going to divide it by 9, the number of sides. So 180 times 7 divided by 9. Okay, so let's clear this out. 180 times 7, 1260 divided by 9. So each interior angle is 140 degrees, right? Because we're only finding the measure of just one of them, not the entire sum. Okay, so example 5, the measure of each interior angle of a regular polygon is 135. Use the regular polygon formula to find the number of sides that the polygon has. So this time they're giving us that one angle, right? What I want to do is I want to set my each interior angle formula, which is this, equal to that one angle, 135. Okay, so it's going to take a little bit of algebra here to solve it, but that's okay. The first thing that we want to do is we want to get rid of this fraction, right? I want to get that n out of the bottom. So I'm going to multiply each side by n. What's going to happen over here is it's simply just going to cancel it out. It does not change anything about this. This is still 180 times n minus 2. But now on the right side, I have 135 n. Okay. Then I want to distribute my 180. 180 times n is 180n. 180 times negative 2 is negative 360, is equal to 135n. Then I want to subtract 135n from 180n. Okay, so that gets me 45n minus 360 is equal to 0, right? Because over here, if this cancels out, there's nothing left. And all I have to do is just add over 360 to set up my one-step equation, right? So 45n is equal to 360. So 180 minus 135, 45, yep. So 360 divided by 45, right? We have to divide by 45. So that means I have 8 sides. So it's an octagon, 8 sides. Okay, so that is everything interior, right? We had a sum of interior angles, and then when it's regular, and I just want to find one, I can divide by the number of sides because they're all the same, right? And I can do it the other way where I'm given the angle and then I have to use my formula to solve for n. Now, the last little bit, we're going to talk about exterior angles of a polygon, which means angles on the outside, okay? So I'm going to put my pencil on an interior angle, right? Like this angle is inside of this pentagon. Here is the angle that's exterior to that angle, right? These are all of the interior angles that I'm putting with green dots. All of the angles that are right next to it are going to be exterior to those angles, okay? Now, we have a very simple rule when it comes to the sum of the exterior angles of a polygon. It's equal to 360. It doesn't matter what kind of polygon it is. It could be a pentagon, a hexagon, a triangle, a square, a nonagon. It could have 92 sides. It does not matter, but all of the exterior angles of any polygon is going to equal 360. And the reason why is because if I connect all of my exterior angles, I form a circle, right? And a circle equals 360. Now, another thing that I want you guys to pay attention to is the relationship between the interior and the exterior angle that's right next to it. I'm going to use this as an example. Here's my inside angle. Here's the angle that's right next to it, outside. These form a linear pair. They add to 180. Okay, so just make sure you understand that, because that could create a shortcut for you when you're finding some of your interior angles. Okay, but it says right here, find the value of x in the diagram below. We know that all of these are outside angles. They add to 360. So I'm just going to subtract all of the other angles from 360, and that's going to solve for x. Okay, so when I take 360 minus 42 minus 61 minus 88 and minus 74, I get 95 degrees. Okay, right here, example 7, it says find the measure of each, okay, there's that word, exterior angle in a regular 12-gon. Okay, so now exterior meaning outside of a regular 12-gon. Okay, remember regular means all sides and all angles are congruent, which means that all the exterior angles are also congruent. So it's real easy. We can just take 360, the sum for all exterior angles for no matter what polygon it is, and divide it by the number of sides. So 360 divided by 12, there are 30 sides, or 30 degrees for that angle.